How do we get our muscles to turn on in the first place? And there are different kinds of muscle fibers? Well, there are actually 3 types of muscle fibers, and you have all of them. And getting them to turn on starts with one of these. Any motor skill you can think of, like kicking a ball, or yes, even a deadlift like this one, requires careful conscious and unconscious planning in the brain in order to recruit the right amount of motor units, and yes, even the correct muscle fibers. It all starts when light bounces off the object you intend to act upon, hitting your eyes, going through your pupil, going through your lens, which focuses it on the back of your retina, which contains those rods and cones, which then turn light into an action potential signal, similar to the one I showed you earlier in this video. It's then going to go through all of these, you can read them here, and then hit your occipital lobe of your brain. This is where that visual cortex lives. It's going to take that signal and shovel it up through the dorsal channel to the postparietal cortex, and through the ventral stream to the temporal lobe. Now these areas are known as the association cortex, and this is where the intent to pick up the weight lives. Now after all the sensory information is combined and integrated in these areas to make sure they have a big picture of what's about to happen, is then sent to this orange area known as the supplemental motor area, that's what that stands for, in the premotor cortex to then initiate the plan by coupling sensory and action planning together. Then all the brain areas we talked about so far will send their information to the basal ganglia, and then we finally get to start actually moving. At this point, the afferent neurons have finished their job in the sensory pathway, and now we get to play with efferent neurons like the motor neuron. At this point, your primary pyramidal neuron is going to be taking that over, shunting it down through your lizard brain, the movement gets smoothed in the cerebellum, then it crosses over here in the medulla before it reaches the ventral horn of your spinal cord. The signal will then take a pit stop in your anterior horn cell, also known as your alpha motor neuron, and then to the efferent neurons, innervating your various muscle fibers. A motor unit is made up of its neuron and all of the muscle fibers it innervates, which means if this guy goes, all these guys go too. Enter the type 1 fiber. These are myoglobin rich and also really rich in mitochondria, which means that they're very energy dense. These will last a very long time and they're great for activities like running a marathon. Over here we have your type 2A fibers and your type 2X fibers. Though it is unlikely that you have any type 2B fibers because of those are typically reserved for animals like grizzly bears, gorillas, and rhinos. Our type 2X fibers are energy poor, but powerful. So this is what I was using when I was doing a 1 rep max deadlift. Here are some cross-sectional scans of various types of muscle fibers. You can see even within the same body you might have a different layout of the different kind of muscle fibers depending on which muscle it is. Now this is Henneman's size principle, suggesting that motor units get activated when they're needed. Because those giant type 2X fibers are so energy poor, they're not really energy efficient to be using. So the only way they're going to get activated is if you lift to failure or do things like 3 rep maxes, 1 rep maxes, stuff like that. So if you want to get big and strong, you got to lift big and strong. If you want to take advantage of biology to up your training game, then follow me for more.